All right, in 3.2, we're going to focus on some growth and decay word problems. So before we get too far into that, I want to make sure you understand some conversions. So you're going to see a lot of these in your word problems. I want to make sure you know that a day is the same thing as 24 hours. A year is the same thing as 52 weeks. Annually means it's going to happen one time a year. A week has 7 days. A year has 365. If something happens monthly, that means it happens once a month, also known as 12 times a year, because there are 12 months in a year. And if it said like 1.5 years, that would be 12 plus half a year, which is 6 months, so 18 months. And then weekly, if it happens weekly, it would be once a week, so 52 times a year. So you'll see those a lot. Make sure you know those conversions. And then let's look at the setup of an exponential function. So y is always going to be our output, right? A we know is our initial value, okay? And then, or our starting value. And then r is going to be our rate of change. So it's going to be our rate, how much we're increasing or decreasing by. And we're going to use that to figure out our b term, or our exponential base. And then x is just going to be our value. So if it was like 7 days or 10 days, that's what we would plug in for that exponent there. But the tricky part about these word problems that we're going to have to pay close attention to is that the rate is sometimes expressed in decimal form. The rate is going to need to be expressed in decimal form for our equation. But sometimes in a word problem, it's expressed as a percent. So we'll have to change that percent to a decimal and then use it to figure out what our exponential base should be. So let's practice changing percents to decimals. So if we had 50%, all you got to do is move that decimal place to the left 2 spots. So this would be 0.50. Whereas 5% would be 0.05. So think about money here. So if you have 2 quarters, that's half a dollar. It's 0.5 versus if you had a nickel, that's only 5 out of 100 cents. So it's 5/100. For 2.8%, we'll move that decimal 2 places, and it's going to be 0.028. And the last one, 32.5, will be 0.325. Okay, but we also have to pay attention as to whether we're talking about exponential growth. So are we increasing or are we decaying? Are we decreasing? So like this first problem, it says your dad bought a stamp collection for $400. So that's going to be our A. That's our initial value. But it appreciates, okay? So it gains value at 2.5% per year. So if I were to write my base as 2.5%, so think about 2.5% of a dollar. If I were to multiply that dollar by 2.5%, I would only have about 2.5 cents, okay? And that's not increasing value. If I were increasing value, I would have my entire dollar, so 100% of that original dollar, plus an extra 2.5 cents. So I would have $1.02 and some change. So $1, 2 cents, and then almost 3 cents. So if I'm doing that, I'm going to first change this to a decimal because our equation needs to be in decimal form. So we're going to have 0.025, okay? And then when I set up that equation, since it's growth, I'm going to add 1 to my rate of change. So I've got y equals my initial, so 400 times 1 plus 0.025 raised to the x, okay? Because it's not just that extra 2.5 cents, it's my whole dollar plus an extra 2.5 cents. So if I were to simplify that, I'd have 400 times 1.025 raised to the x, and that's how I figure out my equation. Now let's look to the right and talk about some pica. So it says the number of pica in a region is decreasing. So that means we're decaying. So we're going to have to start with our original and subtract that rate of decrease from it. So it says there were originally 144 picas. That's our A. And the rate of decrease is 7.5%. 0.98% each year. So as a decimal, we're going to move that decimal place, and it's going to be 0.0798. And since it's decreasing, instead of adding 1, I'm going to subtract from 1. So I'm going to say y equals my original, so 144, times 1 minus 0.0798 raised to the x. And if I want to simplify that, I will just simplify what's in those parentheses. So I'll do 1 minus 0.0798, which means my simplified equation will be y equals 144 times 0.9202 raised to the x. So since we're multiplying by a number between 0 and 1, that will be our decay problem. It will decrease over the years. All right, let's look at a couple more examples. So the population of Hillville is 5,000 people and grows at a rate of 15%. So we start at 5,000, that's A. Our rate as a decimal, we're going to move that over, so it's 0.15. And it says grows, so we're going to add 1 to that. So we've got y equals our initial, 5,000, times 1 plus 0.15 to the x. If we simplify that, it's 5,000 times 1.15 to the x. And then it says, we're taking it a step further, what will the estimated population of Hillville be in 5 years? So 5 is our value. We're going to plug that 5 in for x. So I'm going to say 5,000 times 1.15 raised to the 5th power is going to be my population after 5 years. So what I'm going to do is I'm going to go to Desmos and I'm going to type that in. Let's do that. So we're going to say 5,000 times, what was our value? 1.15 raised to the 5th power. So that means our population is going to be about 10,056.7. And I'm going to go ahead and round that to 10,057. Okay, because you can't have a portion of a person. This one says your grandma bought $30,000 worth of stocks. The economy went into a recession and she lost 11% per year. So 30,000 is our initial. Our percent in decimal form is going to be 0.11. As an equation, since we are losing money, this is decay, so we've got y equals 30,000 times 1 minus 0.11 to the x. If I simplify that, I've got 30,000 times 0.89 to the x. And then it says how much money will be in the account in 8 years. Well, let's type that into Desmos. We're going to plug in 8 for x. So we're going to say 30,000 times 0.89 raised to the 8th power, because 8 is our x value. And so after 8 years, she's going to have about $11,809.77. So she lost quite a bit of money there. Another example, so suppose you have $300. You invest this money into an account earning 6% interest each year. So you're earning, that's growth. We started with 300, so that's our A. Okay. So let's go ahead and write 6% as a decimal, so that's going to be 0.06. As an equation, we're growing, so it's going to be y equals 300 times 1 plus 0.06 to the x. If we simplify that, we'll combine our parentheses, so 1.06 to the x. And how much money will you have after 2 years? We're going to plug that in for x and evaluate. So we're going to do 300 times 1.06 raised to the second power. So that's going to be $337.08. All right, let's do one more example. The initial number of bacteria in a petri dish is 200, so that's our A. It is decaying at a rate of 15% per hour, so we're going to change that to a decimal, 0.15. Set up an equation, so y equals our initial, which is 200, times, since it's decay, we're going to do 1 minus 0.15 to the x. And if we simplify that, 1 minus 0.15 is 0.85, so y equals 200 times 0.85 to the x. Approximately how much bacteria will be left after 1 day, so we're going to plug in 1 for x. And if we do that and evaluate, we've got 200 times 0.85 raised to the first power, and that's going to be 170. So we've got about 170 bacteria.